Hello everybody, let's understand how to implement linear regression using TensorFlow. This is a fundamental concept. If you understand it well, you will very easily grasp what happens in neural networks and so on. Let's start. So we see here we have what do you have to predict? We have to predict model parameters A and B in case of linear regression. As you understand, how do you define linear regression? Output is equal to ax plus b. That's what we intend to do. Okay, what we have to predict? We have to predict this model parameters A and B, and we are trying to do a simple linear regression, a straight line basically. Okay, let's see the entire process, how it happens. The first thing is initializing model parameters. Okay, so from our previous concept, okay, we realize that when it is variables, right, they will try to modify the model parameters with every run. Okay, so so A and B will be your variables of TensorFlow, which will undergo changes with every iteration. Okay, so these are your model parameters. Before the model in fact starts, we'll initialize this model parameters with some random values. There are a lot of concepts around how to initialize these model parameters. For simplifying the stuff, we'll use random numbers to initialize them. After having this these parameters initialized with some random values, we already have an equation where A is replaced by some value and B is replaced by some value. When you pass training data, in this case we are doing simple linear regression, one feature data, one target data. Okay, so we'll pass one feature data in place of x, and we'll get one target value. Since the regression, it will be continuous value. So when you pass input data, that is x in this case, you will compute loss. Loss is your, in case of linear regression, root mean squared error. That means sum of square of difference between actual value and predicted value. We know the actual value in this case. Actual value is target value that you are passing in the training data. We predict the predicted value using this function ax plus b. So with some data, we'll call them batch. In this entire concept of machine deep learning, we'll use a concept batch. That means a randomly chosen section of the data that you are passing to it, and using that it will compute the loss function, and after it computes the loss function, based on this loss function we'll modify the initial parameters. So that's how it proceeds. First time you randomly initialize the model parameters, you use the training data to compute loss. Using those computed loss, you readjust the model parameters, and you do till the point you achieve the intended loss. Okay, let's now try to see how this happens in the code. Okay, first thing first, we'll import NumPy. We're importing TensorFlow. We are resetting the default graph. This is quite useful if you are using a notebook based environment, resetting the default graph so that whatever values we have initialized in the graph get reinitialized. Okay, now this is the point we are generating data. This is pretty interesting here because we really want to test if linear regression really works with TensorFlow. So what will we do is we'll actually generate data of our interest. Okay, so that we know that this data is correct, and we will cross verify linear regression. Let's see. So what we are doing here, we are generating 10,000 samples of data. Okay, linspace NP linspace 0 to 10, 10,000. That means between 0 to 10 it will generate 10,000 samples, equally spaced data. Okay, then you are doing a y is equal to 2x plus 5. So this is the pattern of data. What we intend to do now is we want to predict this 2 and 5 from this data. We'll pass x and y to our algorithm and we'll try to predict 2 and 5 there. Let's see. As we discussed earlier, what is the first thing we do? Our A and B will be variables. Since this is the value which will undergo changes after every batch training. Every cycle that it happens, there is a batch. In this case, we'll have a batch of size 100, let's say. Okay, and every iterations 100 data will be given. It will compute loss for it, and based on the loss, the model parameters will be adjusted. So these are the initial parameters, and we are initially randomly initializing them. That's what is happening in this case. Now, based on our previous understanding of placeholder are a promise that you will pass data from outside. In this case, you will be passing training data from outside. Okay, let's see. So this is the placeholder, and you will have x data and y target. You have one as training feature data, only one column, okay, the x column that we generated out here, and one column is target data. So we'll pass that. We are creating a placeholder so that in future we will be passing this data when you will be running the model. Now we have to implement the logic. Okay, in this case it is ax plus b. That's precisely you are implying to implement over here. The order of the x and a is changed because we have to do matrix multiplication here. So we have to take care of the dimension since we are writing a very low level code. Okay, so you have to write x, a and b, you can see, and this is the model output. Okay, and we have to compute loss. In case of linear regression, the loss is root mean squared error. Okay, so that's how it is. This is the predicted value, this is the actual value, and this is the difference between them. You are doing a square of it, this sigma 1 to m, where m is the total number of inputs. Okay, so this is sum of square of difference between them, and you are doing it divided by 1 by 2m. When you divide by 1 by 2m, this is basically equivalent to doing a square root. This is mostly meant for easing the mathematical calculation. Okay, this is the cost function, and we intend to implement this here. Okay, precisely this is what we do here. Reduce sum in TensorFlow. That means for each value it will do a cumulative. It will show an accumulative behavior in this case. Okay, so this is the actual output. This is the this is the predicted output. This is the actual output. You are doing a square of it, then you are doing a sum of it, and you are dividing it by this data. This is basically implementing this in TensorFlow. So let's understand what is gradient descent. Gradient descent uses cost to find the best model parameters. Okay, what typically it is, right? Let's say you are plotting a graph with 2D matrix with all cost. Okay, we have theta 0 in x-axis, theta 1 in y-axis, and for a particular combination of theta 0, theta 1, we have a cost function. So gradient descent is the algorithm which from this matrix can find out the best coefficients for which the cost is least. Okay, for this it needs a learning rate, which is basically jump size across the matrix. Okay, so this is what you are configuring here. We are, in this case, we are choosing a learning rate by our assumption. Of course, this may not work always. You might have to tune it less, tune it more. So this tuning is something that we learn later in the course. Okay, so as of now we are making it 0.5. So you are creating a gradient descent object with a learning rate of 0.5. And the intention of gradient descent object is to minimize the loss and find coefficients corresponding to it. Okay, and that's what we are doing here. So this is the train process. GD is a gradient descent object. You are minimizing loss. So this is the final object which is dependent on the entire graph. So if you call session.run with train.process, it will execute the entire graph. Now this is the iterative part of the code. Okay, so what will you do now? We have configured here a batch size of 100. Very important here to understand is that this is the 100 data. It will pick up from our 10,000 data randomly. This is what our NP random choice is doing. It is picking up 100 data from it. Okay, and every time it will take 100 data from the entire lot, pass it to the training model, find the loss. Based on the loss, it will recompute or readjust the initial parameters, and this drill will happen till you get a satisfactory loss. Okay, we'll try to implement this code over here. Okay, so this loss info is a list where we will store all the loss information so that we can plot the graph or see the information. Okay, so and what are you doing here? A and B are your variables. We need to initialize them before we could use them. That's what we are doing here, and all this code happens inside session. So that's what we are putting it inside session. Now we want to do some 5,000 iterations. That means 5,000 times we want to pick up batch size data, compute loss, change the or readjust the model parameters. So 5,000 times we are putting it over here. This is what is randomly choosing 100 data from the entire lot. This is the X data, this is the Y data. You are doing a session.run. Okay, when you are doing a session.run, this is the object which is dependent on the entire graph. So if you want the entire graph to be executed, we are doing train.process and feed dictionary. Remember, we created this placeholder for getting the training data. Okay, we have this placeholder. This is another placeholder to get the training data. Now, okay, so we need to pass the training data. So this is the place. So we are passing the training data here, but keep a check on this NP transpose that we are doing here. The purpose of this NP transpose is because this machine learning models always requires data to be in rows of column format. Data should be in rows of column. To make it happen, we are transposing it. Okay, to make it one dimension data into rows of columns. So you are passing the X data, passing the Y data. You want to store the loss also, so you are storing the loss information in loss.info. You're passing the data in the same way, and of course you want to print the value of A and B after every 1000 iteration. So that's what you're doing here. Okay, session.run A and B, so that we can print value of A and B after 1000 iteration. And TF summary file writer will actually dump the the graph, tensor graph, into this file, which we have seen earlier how to see it, and we are finally dumping it over here as well for our further understanding. So if you execute this code, we'll see that after 1000 iteration, the value of A has converged to 0.7 and value of B has converged to this is the first iteration. So if you execute this graph for 5000 iteration, we'll see that during the first execution, this is the output. That means first time the value of A and B was initially assigned as 0.7 and 0.8. These are the random values which was first time assigned. After first 1000 iteration, the value of A has changed to 2.17. How this has happened? First time it uses the random values to calculate the loss, readjust the model parameters. So first time itself, after first 1000 times, this is the A and this is the B. So now we see after 5000 times, the value of A has converged to 2.001 and value of B has converged to 4.99. Aren't they very close to the the expected values? As you see here, the expected values are 2 and 5. So based on the data, it is actually able to calculate some 2.001 and 4.991. Right? Okay, so it is able to calculate. So what does it look like? So TensorFlow is able to solve our linear regression. So of course you can make it complex. You can create polynomial regression here or any other form of it. This will be able to do it. Now let's see the graph that is generated over here. Okay, so you can see this is the random number. We are initializing this variable. This is another variable. We are initializing that. We are doing out like mx plus c, right? The coefficient, we are multiplying the coefficient, getting the output here. You can tally the entire graph. It will be depicting the entire model that is created out here. And if you want to see the losses, you can see we began with loss of around 0.67, and by the end of the training we came to pretty close to 0.001. Okay, and further down. Okay, so in the entire process we have reduced the loss as well. Okay, so this should give us a good understanding, how linear regression really works and can be implemented using TensorFlow. Okay, see you in the next session for the following topic. Thank you.